Grade 10s, this is Euclidean geometry revision pack that was compiled in 2019. So I'm going to help you through it in terms of trying to make you understand about how do you approach these Euclidean geometry questions. So, but if you really want to try a question, just pause the video and come back later for the solution. So let's start with the first question. So this one was taken in November 2018. Then it says, question number 7, complete the statement so that it is true. So questions like this, you just need to know that the theorem says this. You can actually give the full definition of a given theorem. So here, a line drawn from the midpoint of one side of a triangle parallel to the second side, you just need to know that it bisects the third side. So it's bisect the third side, right? Bisect the third side, right? So it does what? It bisects the third side. And we also know that this theorem continues to say this side, it also have the second side. So we just have this, and you can see that this is just the what? This is just the converse of midpoint theorem. So we are having this line, and this line is cutting this one into two equal halves, and it is parallel to the second side. So we just need to know that it also bisects the third side, right? So we just have that small kind of the explanation over there. So coming to 7.2. 7.2, we are having a very nice diagram that might be confusing, but you just need to know where to focus and how do you get the missing information. So in this one, ACS is a triangle. So we are having this triangle over there that it is given there. P is a point on AS. So we are having this point, and R is a point on AC. So we have this R, which is in the point in what? In this line AC, such that PSRQ is a parallelogram. So we are having PSRQ, which is this one, is what? Is a parallelogram, right? So once we have a parallelogram, we just need to know that this side is parallel to this side, and as they have to also be equal to each other. Then also this side is equal to this side. But anyway, just know that information. Look, now, which means this side is equal to that side, right? Due to the fact that the opposite sides of a parallelogram are always equal. So this is the information that we get from this parallelogram. We can also show this, indicate this parallel side. Then we know that we're given that PQ intersects AC. PQ intersects AC. PQ intersects AC at B, such that B is the what? Is the midpoint of AR. So since this is AR, and if B is the midpoint, that means it divides these lines into two equal halves, right? So we have that information. So coming to this one, QC is joined. So QC, this is QC, it is joined over there. So also it is given that CR is equal to PS. So this is the information that we have, that this side is equal to that side, and we can see the denotation here that this line is given to be equal to this side, even in the diagram as well. So C1 is equal to 50 degrees. Then this is something that we can just add here so that we don't forget that we have that information. So we also have BP is given to be 60 millimeters. So BP is this line over there, so it is equal to 60 millimeters. So we have that information in this diagram that we have to use it effectively to find the missing information. So 7.2.1 says, calculate the size of A. A is there, so we need to get there, finding the size of that angle A. So how do we go about doing that? It is very important that since we are given this C1 being equal to 50 and PQ or PSRQ is a parallelogram, so we know that BS is equal to QR. This is QR. So this is what we have. The reason is these are the opposite sides of a parallelogram. So these are the opposite sides of what? Of a parallelogram, right? So of a parallelogram. So this is how you shorten parallelogram. Then we can talk about Q1 now. Q1 is now going to be equal to 50 degrees. So the reason is this since this is 15, then the for opposite sides, they have to face opposite equal angles. If the sides are equal, if there are sides that are equal in the triangle, so the angles that are facing those equal sides, they have to be equal as well. So which means this Q1 is equal to C1 over there. So this is basically what we have. So we say equal angles. Okay, no, these are the sides that are equal sides. Okay, so these are the angles that are opposite equal sides. So we have that one, Gengoku, right? So that is why Q1 is now equal to 50 as well. But we can see that this R3 is the exterior angle of this triangle. So we have R3, which is equal to 100, because this is the exterior angle of a triangle QCR, right? So we know that the exterior angle is equal to the sum of two opposite interior angles. But anyway, it was also given that QPSR, this is the parallelogram, right? So if this is the parallelogram, then therefore this line is also parallel to this one, right? So once we have this parallel line, we can see that this PS continues to be parallel until that point A. So which means even this side is parallel to QR as well. So if that is the case, then therefore the alternate angles have to be equal if they are lines that are parallel to each other. So that will make A3, no, not A3, A in general is equal to R3. They are both equal to 100. Reason, these are the alternate angles. So we have alternate angles equal to each other because they are lines that are parallel to each other. So we have AS over there. So we have this information and we managed to find the numerical value of A. Coming to the second question, determine the length of QP. So determine the length of QP. This is our QP over there. So how do we go about doing that? The first thing is to see that at first we were to complete the statement over there, and we can see that we are completing the statement that tells us about the converse of midpoint theorem. So we can see that here as well is being shown that B is the midpoint. Then if that is the case, and this line BP is actually parallel to the second side RS, then if that is the case, then therefore this is the converse of midpoint theorem. So that means BP is going to be half of what? Of RS. So that means BP is that means RS, if that is the case, is going to be equal to 2 times 60. Sorry for that. So this is 2 times 60. That will make 120 millimeters because of that. So what are we having now? This is the converse of midpoint theorem. So we are having that one. So that is why RS is now equal to 120. But the idea was to find the line QP. So QP is now going to be equal to 120 because these are the opposite sides of a parallelogram, right? So we are done with 7.2.2 because once this is 60, then this one has to be 120, and this is 120. It has to be equal to that one, which is also going to be 120 because these are the opposite sides of a parallelogram. They have to be equal to each other. Coming to this, the next question. The next question comes by this is ABCD that is said to be a parallelogram, right? So ABCD, this is a parallelogram, right? So if that is the parallelogram, then we have E is a point. E and F are the points on AB and DC respectively, such that AE, you can see that AE is now equal to FC. D is produced to J and CJ is drawn. BF is produced to K and AK is drawn. So we all have this information now. Now, the question says, prove that DJ is parallel to BK. So this is our DJ. This is DJ, which are prove that it is parallel to OPK. So how the lines get parallel to each other? It is when they are okay, yes, you want to give it a try. All right, it is when the alternate angles that are found equal, or if they are corresponding angles that are equal to each other, or if they are co-interior angles that are supplementary to each other. So when those three things, one of them, if it happens to those lines, then therefore those lines are said to be parallel to each other. So we just need to find one of that relationship, either the alternate angles being equal to each other, corresponding angles if you have any, or the co-interior angles if they are supplementary to each other. So in this case now, we just need to first identify which angles could be equal that will make this to be parallel to each other. So which corresponding angles that has to be equal, or which alternate angles has to be equal to each other. So like for example, this is an example of alternate angles, that since these I'm sorry for that, so which means this must be equal to that one. So, or if not, we just need to know that probably this E3, if it is found equal to B2, then you can see that these angles are corresponding to each other. So should the corresponding angles found equal, then therefore these lines are parallel to each other. Or probably you can see these corresponding angles F3 and D1, if they are correspondingly equal, then therefore these lines are parallel to each other. So we can even view other aspects here for parallel, for alternate angles, corresponding angles, and stuff like that. Whichever way that you found it easy to prove, then therefore you can just go for it. To questions like this, you just need not to go away with congruency. When you have triangles and you want to find some close similarities, you can see that congruence does work, or does its best to help you find that relationship. For example, in triangle EAD and triangle BFC, you can find that these triangles, they have a close relationship such that they share some common properties. On that note, let's just say we would love to make this D1 being equal to F3. How are they equal to each other? Now, we know that in triangle AED and triangle BFC, what do we notice? We notice that angle A as a whole is equal to angle C over there. So this angle is equal to that angle. The reason, these are the opposite angles of a parallelogram. We've been told that this is a parallelogram, so the opposite angles are supposed to be equal to each other. So A is equal to C. Reason, these are the opposite angles of what? Of a parallelogram. Then we also have AE being equal to FC. Then the reason there is given, right? So we also have what you call AD. AD is equal to BC. What is the reason for that? Opposite angles of parallelogram. So should that happen, you can see that since this side is equal to this side, and this side is equal to this side, and this angle is equal to that angle, we have side angle side. So that means that triangle AED is congruent to triangle BCF. So the reason is side angle side. So we have that. So if that is the case, then we can tell that what you call F3 E3, and E3 is then equal to F3, because this is from congruent triangles. So this now this now is going to be equal to this one, because these two angles, they are facing equal sides. This A3 is facing this AD, and this F3 is facing this BC. You can see that both of these sides are equal to each other, and they are supposed to be faced by equal angles. So that is why E3 is now found equal to F3. So these are the equal corresponding angles in these congruent triangles. So, but we also know that D1 is equal to E3. Why is that? It's because these are alternate angles, right? These are alternate angles. And alternate angles are equal because line AE is parallel to line DH. So we have that. So if that is the case, if F3 is equal to E3 and D1 is equal to E3, which means F3 is equal to D1. So which means if this F3 is equal to E3 and this D1 is equal to E3 because of alternate angles, then therefore D1 is equal to F3. And they are both equal to E3. So we just have that. So you can now conclude to say, therefore, DJ is parallel to BK, raising the corresponding angles are equal to each other. Should that happen, then therefore the lines are parallel to each other. So can we then get into the second one, which is 4 marks? We have E1 equal to F1. We need to prove that E1 is equal to F1. Where is F1? This is F1. So we need to prove that. So you can see that there isn't much close relationship between these two angles, but we can do our best to do that. So E1, first of all, is equal to E3. And we can see that these are vertical opposite angles. They have to be equal to each other. These are vertical opposite angles, right? They are always equal to each other. But we have proven that E3 is equal to F3. We did prove that, right? So we can just say proved. And F3 is equal to F1, raising vertical opposite angles. Okay, vertical opposite angles. So if that is the case, if E1 is equal to E3 and F3 is equal to that, so both of these angles are equal to E1. So we have E3 equal to E1. We also have F3 equal to E1. That means F1 is also equal to E1. Therefore, E1 is equal to F1 as well. So because of that kind of thing, right? Now, we are done with 8.1.2. So let's get into another question. This is a lovely question because there is a circle, there is kite-like thing, but anyway, let's get it along. What are we having now? In a diagram below, O is the center of the circle, this is the O. Then A and B lies on the circumference of the circle. AP is equal to BP. So we have this AP is equal to BP. Not me, it's AP, but this one. All right, so the idea is to prove that AT is equal to BT. So we need to prove that this line over here is equal to that line, right? So basically, by the look of the diagram itself, we can see some properties of a special quadrilateral over here. So you can think of a kite. So now we can tell that AP, because this is 5 marks, AP, all right, so we can just we can just say AP is equal to BP raising that's given, right? Because we are given this information that this is equal to that, right? All right. Then we also have OA, which is equal to OB, and the reason here is that these are equal radius. Okay? So by having that, we can see that if two pairs of adjacent sides are equal to each other, then therefore this has to be a kite. So therefore A O B P is a kite. This is what was not given. We were not given this. This is the kite. Then reason, because two pairs of opposite sides are equal, right? Now, once that happens, we know that AT is equal to BT, BT. The reason for that is because the properties of a kite, right? So we can just say the shortest diagonals of a kite. This is the shortest diagonal or diarc of a kite. We know that the shortest diagonal of a kite is being bisected by the longest diagonal. So we can just tell that. So we managed to prove that this is actually equal to each other. So then OTA, we had to prove that OTA is actually 90 degrees, right? So angle OTA, I don't think we need to do calculations here. We can even see the mark. It's just one. Angle OTA has to be equal to 90 degrees. And then, so we can say this is because of diagonals of a kite. So this is it. So because we know that the diagonals of a kite, they intersect at 90. So we can just say they intersect at 90 degrees, not necessarily bisecting at 90 degrees, because only one diagonal that is being bisected, the longest one is not. So they just intersect at 90 degrees. That means T2 is 90 degrees, T1 is 90, so do T3 and T4. So this is just the presentation of this question 8.2. Let's come to the other one, if there is any. Coming to this one, question 8, KLMN is a rhombus with diagonals intersecting at O. So we have these diagonals, they intersecting at O. They are not telling us that they are bisecting. We just need to know that the diagonals of this special parallelogram, which is a rhombus now, they bisect. Also, they bisect at 90 degrees. This is just a hint that things that you need to remember about the special quadrilaterals that are parallelograms, like these rhombus that we have right now. Now, it is given that KLM is given by 34 degrees. So this is our 34 degrees over there. So the question says now, write down the size of O1. So the size of O1 is basically equal to 90 degrees. So it is very wise that you write the reason diagonals of rhombus. So diagonals of rhombus, they bisect at 90 degrees. You just don't have to mention that all, right? Then calculate the size of L1. Size of L1, the size of L1 is this one. So we need to calculate the size of L1. So it is very important that we just use the basic algebra together with this Euclidean geometry idea on how to find L1 when you are having that one. I think you have already got the answer that when you are having this, you can see that this angle plus this angle plus that angle, they have to give you 180 degrees. So if you have 90 here, so you are going to be having 56 here. If you have 34 there, so you need 34, you need 56 to add up this and this one. They have to give you 90 degrees. Otherwise, the sum of all interior angles in the triangle, that are supplementary to each other. Now we can tell that L1 L1 is equal to 56 degrees, then the reason is actually the sum of interior angles of a parallel of a triangle. Sum of angles in a triangle. So we have that. So this is 56 degrees. So calculate the size of K and M. So K and M. So this is K and M. So we are having this one, which is this whole angle over there. So it is very important that we remember the diagonals of a rhombus, that they bisect the corner angles or they bisect opposite angles. So if you have 56 here, you must have 56 here as well. So this is 56 plus 56, that's just 112. So now what are we having? What you call angle L. First of all, we can just say angle L is equal to what you call, this is 112 degrees, which is equal to, the reason is diagonals of rhombus, right? Diagonals of a rhombus, After that, you can just tell that this K and is equal to 112 as well. Reason, these are the opposite angles in a what? In a parallelogram. So we have this information now, that if this angle is 112, so does this one as well, because they are opposite angles of a parallelogram. This is also a rhombus, but the rhombus is a parallelogram. So we are done with this one without any hiccups. Now coming to number 2. Number 2 says, given the parallelogram PQRS with diagonals PR and QS intersecting at M. So here we have these diagonals, and this is the parallelogram that is provided to us. Now coming to this question, prove that the diagonals bisect each other. How do you go about approaching this question? The idea is to find the relationship between two triangles that are congruent, that you can prove to be congruent to each other. So it is optional that you can take this one and this one, or you can take this one and that one. So it is very important that you take this side PM and also MS, which gives you MQ and MR. So you can see that I'm just breaking down these things so that you see that we just need to prove that this line is equal to that line, which means this line is bisected, and this line is equal to that line, which means it is bisected. So we just need to prove those things. So it is very unwise an idea to use this one and this one. So we cannot use these ones. We cannot use the diagonal as a whole. It has to be something of this kind, and also that one. So let's just prove these ones. The one that I just highlighted, that in triangle PSM and triangle QMR, what do we notice here? You can see that M4 is equal to M2. Reason, these are vertical opposite angles, right? So we can also talk about what P1 is actually equal to R1, and the reason is these are alternate angles. This angle is equal to that angle. They are alternating. These are alternate angles, equal because of line PS is parallel to line QR. So we have that. Then we can just also talk about this side PS, because we cannot find all three angles, because we don't have the condition for angle in the what when you're proving incongruency. So you have to have angle side. So we're just looking for another side instead of looking for the third angles, because we know even though they are equal, but we cannot use the angle in proving what called a congruency, because it could be not that could be just the triangles are similar if they have all the corresponding angles that are equal to each other. So that is why we just run away from proving that all angles are equal. That one is going to occur automatically. So PS is equal to RQ or QR there because of opposite sides of what? Of a parallelogram. So we have that. So therefore, a triangle PSM is congruent to triangle this is QMS. The reason for that is because because we have proven angle side, right? So we can then conclude to say therefore what PM is equal to MR. So we basically have that. So no, MR, so we have that. So which means PM is now equal to MR because they are facing equal angles, right? So they are facing equal angles. No, I meant to say this is equal to what? So we have these triangles, this triangle over there, this is facing that one, and this is facing P1 is equal to R1, P1 is equal to R1. So also we are saying PM, we can say SM is equal to MQ because this one is facing P1 and this one is facing R1. So we just have that. So this is what we have. Or we can just take this triangle and this triangle, proving the very same thing, so that this side is going to be equal to that side, so that the two pairs of diagonals to bisect each other. So we basically have such information. So this is basically how you prove the bisection of diagonals in a parallelogram. So let's check if there is any other question over there. So what's a nice question? In the diagram, ABCD is a parallelogram with a diagonal intersecting at E. This is the E that we're talking about. The diagonal of a parallelogram DECF intersects at G, right? The diagonals of a parallelogram FGCH intersect at K, so we have that. Then the idea is to prove that DB is equal to 4KC. So this length of DB is actually multiplying for UCK or KC by 4. So it is very important to start by understanding the parallelogram at large. So if this is the parallelogram and you also have this parallelogram and this other parallelogram, because we have three parallelograms, we have this one, we have this one, we also have this one. So if we have three parallelograms, which means we do have a lot to talk about. Now it is with idea that DE is equal to, or we can just say DB is equal to 2DE, right? So if you can repeat DE twice, you can find the whole length of DB, because if this one is equal to this one, so DB is equal to this side times 2, right? So we just have that. Now we all know that DE, okay, let me just say these are diagonals of a parallelogram. Diagonals of parallelogram. So the diagonals of parallelogram, they have to bisect each other. So since we have this, so DE is just half of BD. So that makes BD to be twice DE, right? So but DE is actually equal to FC, or FC, yes, FC, Reason, these are the opposite sides of a parallelogram. Alright, opposite sides of a parallelogram are equal to each other, so which means this one is equal to that one. All right, let me just use the different color. This one is actually equal to that one, right? Because this is the parallelogram, remember. Okay, now that means we have that. So we actually have B, let me just use this one, DB, which is the very first statement. I can just modify it. It is equal to 2 times DE. 2 times DE. What is DE? It is the same as FC, right? So we have that. We just substituted from here. In the place of DE, I just put UFC. But FC over here, FC, which is this length, it is just twice this FK. You can see that GCHF is a parallelogram. So that means this GH is bisecting this line over there into 2 equal halves, right? So that means we can actually say, since this one is equal to that one, that means BD is equal to 2, then FC, but FC, we said FC is equal to 2 KF, right? Is equal to 2 KF, which means now if we have AC, we can just multiply this KC twice by 2 to get the whole length of the diagonal CF. Now that we have one case in the place of, we have BD, in the place of FC we put UKC, right? So we can still repeat the same thing, which is that this is diagonals of a parallelogram. Diagonals of a parallelogram, they are what? They bisect each other. So we can just simplify this. 2 times 2 is 4, then it's 4KC. So we did prove that. So you can see that there was a bit of link and confusion somehow, but once you take your onkelento, that this one is just squeezed to travel this DE twice to get DB. So this is what we have. But in the place of DE, because we were trying to move from here down to KC, so how do we go about breaking down all these half diagonals? So it helped us to get into this this road. Let's check if we have another question. Another question is quite straightforward. We have triangle ABC, which is a right angled at B, which is a right angled at B. So we have this. F and G are the point of AC and BC respectively. H is the midpoint. H is actually the midpoint of AG, which is, this is AG that we have over there. So H is the midpoint of that, and you can see the lines that are being shown here, that there's things that are equal to each other. E lies on AB such that FHE is a straight line. FHE is a straight line over there. Now prove that E is the midpoint of AB. Prove that E is the midpoint of AB. So this E, meaning that these lines are supposed to be equal to each other. We are to prove that. All right, but it is very wise to remember that HF is parallel to GC, right? This HF is parallel to GC because this is the line drawn from the midpoint of both sides of a triangle. So this one, this F is the midpoint of AC and H is the midpoint of AG. That means this line has to be parallel to the third side. So if a line is drawn from the midpoint of two sides of a triangle, it is also parallel to the third side and also have the third side. So we have that information that FH now is parallel to GC, raising midpoint theorem. So sorry for that, midpoint theorem. right? So we have that. Now, after knowing that this line is parallel to this other side, that other line, we can tell that it continues to say EH is also parallel to BG, because this is just a continuous straight line, and from being parallel, it is still going to be parallel over there as well. Now we can tell that now this is parallel to this one. This is just the explanation that you have already indicated above. Now, if that is the case, we can tell that E is actually the midpoint of AB. And the reason for that, this is the converse now, because we are given that this line is parallel to this line, and this H is drawn from the midpoint of the second line, so it has to also bisect this other line over there, right? So we can tell that now E is the midpoint of AB. Reason, this is the converse of midpoint theorem, right? So we are done for that one. So if EH is 3,5 centimeters, if EH, so let me just squeeze it up, sorry for that. So if EH is equal to 3,5 centimeters, so this is 3,5 centimeters, then the area, and the area of this is 9,5 centimeters squared. Then calculate the length of AB. So we have this, then therefore the area of AEH, the area of this triangle is equal to 9,5 centimeters. All right, so this is 9,5 centimeters squared. Then therefore we are to calculate the length of AB. Well, the length of AB is basically going to be what? We must know something here, that if we have that, and we just need to remember that if this line is parallel to this one, then angle E is going to be 90 degrees as well, because these angles has to be correspondingly equal to each other. So we have that, which means we have a right angle to triangle over there. So which means the area of this triangle is going to be equal to half times base, and our base is EH, times height, and our height is AE. Then we just have that. Then the area is actually equal to 9,5, then is equal to half, then EH is equal to 3,5, then times AE. Then AE, if we can just slightly use our calculators, so 9,5 times 2 is basically 19, then 19 divided by 3,5 is actually going to be 5,43 centimeters. We can just say centimeters. So we have that, and therefore, since they are looking for the length of AB, then therefore AB is equal to, then if you can just plus or times that by 2, or the answer then times by 2, then you're going to get 10,86. So we have that. This is this length is going to be 10,86 if we run off into two decimal places. So we have that. So hence calculate the area of triangle ABC, area of a triangle ABC. So it is very important now to use the information that we have that the longest, the height of this triangle is actually 10,86. Then we also know that BG is actually doubling this EH, is equal to 2 times EH, and the reason is because of midpoint theorem. Now that we did prove that this side is equal to that side, so we do have midpoint theorem. So we have midpoint theorem, right? So that means BG is going to be equal to, if we have 3,5 times 2, which is going to be 7, right? So we are going to be having 7 centimeters, right? BG, I meant BG, which is this length over here. Since it's doubling this one, it's what? It's 7. So that means since you can just say since OGC equals to BG, therefore BC is now going to be 14 centimeters, because this 7 plus this 7, then they have to give us 14 centimeters. So it is very wise now to also calculate the area of ABC that way. So area of ABC is given by half. Then the base is going to be 14 times the height is just 10,86. Then we have that. So answer we have what? We just have half, then times 14 times 10,86. So the answer is just equal to what you call 10,86. That's basically 76,02 centimeters, right? Centimeters squared. So we actually have that information over there, which is not the highest things to think about. Let's just get into another one, if there is any. Wow. Question number 8, November 2016. Complete the following statement. If the opposite angles of quadrilaterals are equal, then the quadrilateral is a parallelogram. I think you can just put the parallelogram here in full. Don't write this one. So if the opposite sides of a quadrilateral are equal, then that quadrilateral is a parallelogram. So you need to just sing these theorems because they are really communicating with you. Now, use the sketch below to prove that the opposite sides of a parallelogram are equal. The opposite sides of a parallelogram are equal. So it is very important now when you get this question, just quickly go through a congruency. How do you use your congruency to find that this side is equal to this side and this side is equal to that side, right? All right. Now, let's get into it. You identify the triangles, then you prove congruency, then you conclude thereafter. Then you get that 4 marks here. Then in triangle ADB and triangle DBC, what we notice is that D1 is equal to B2. Reason, these are alternate angles. These are alternate angles because AD is parallel to BC, right? So we can also talk about angle B1. Angle B1 is actually equal to D2, and the reason for that is alternate angles also, because AB, which is this line, is parallel to that one. So because AB is parallel to OTC, so we can also tell that BD is common, or BD is a common side. So we have that. Then therefore, once we have these 3 items, then you can say therefore triangle ADB is congruent to triangle DBC, BC, then the reason for that, it's angle side. So we have angle side. We have proved two angles that are correspondingly equal and one side over there. So we have that. So we can then conclude to say now, okay, therefore AD is what? Is equal to BC and what? And AB is equal to DC. Then the reason is from congruent triangle. So you just have that, right? You just have that. So we are done with that, because we were proving that opposite sides of a parallelogram are equal. So yours is to just prove the congruence on this triangle and prove the congruence in this triangle. Then therefore you are on the go. Coming to the next question. The next question says, show that NOM is 90 degrees, then prove, and the second one, it says prove that O is a midpoint of what? Of KP. So you need to prove that this is 90 degrees, and the second one is to prove that this line is also equal to that line. So I just want to leave this one with you to find a way to connect the dots and find the solution about this one. Otherwise, I believe that the next video I will be showing this before I continue with the next stuff about Euclidean geometry. So you are free to pause the video to attack a certain question that you're interested in, then come back for the solutions. Otherwise, I'll continue in the next video for the completeness of this worksheet. Thank you guys. Enjoy.